Hello guys, in this video I'm going to show you how to solve subset sum using bottom-up approach. In the previous video we've solved it with top-down approach, right? So we start with the original problem and recursively solve subproblems. But for bottom-up approach, I want to use a two-dimensional table, right? But first, let's go to the requirements again. Given a set of positive numbers, determine if a subset exists whose sum is equal to a given number s. Right? A set 1, 2, 3, 7, 0, 1, 2, 3 is the index. Right? So the target sum is 6. Right? So is there any subset that sum up to 6? Right? We can easily see that 1, 2, 3 is a subset like that, sum up to 6, right? So for this problem, I want to use two-dimensional table. The first, the column will run from 0 to sum, right? And the row will be the row will be the index of our input, right? So index of every numbers, of our input, right? So here actually it should be, wait a minute, okay, here is 0, 1, 2, 3, right? So 0 means the first number, 1 means the second number, 2 means third number. So here the index 0, 1, 2, 3 is the index of each number from the input, right? So each cell of the table will be the answer, will be a subproblem for the questions whether we can find a subset, whether a subset exists that sum up to given sum, that is the row. For example, here for example, x will be the answer if a subset exists whose sum up to 1 using the setup considering only the positive numbers at index 0, right? Which is 1, considering only 1. But what if here, what if cell y, it will answer, it will determine if a subset exists, the sum up to 2 considering the input from here all the way upward, right? Which means we consider every number from index 1 upward, which means including 1 and 2, right? These two numbers. So example, Z here will be the answer. Forgot, XYZ will be true or false, right? So C will answer whether a subset exists or sum up to 3 using the input from index 2 all the way upward, which is 1, 2, 3, right? So wanna build up our table from left to right and from top to bottom, right? So we'll start from here, and every and current cell will be solved using the previous cell, right? So current problem will be solved using the previous problems that we've already solved. But in order to do so, we must have a base case for our table, right? We must have some assumptions that we're sure to be true. So what is that? That is normally the first row and the first column, right? So if we look at the first column, it will be the answer using this given, considering this input. Can we find subset sum up to 0? So for this question, it's always be true, because for a for any subset, for any input, we always can find a subset that sum up to 0, which is nothing. We just pick nothing, right? So for the first column, we can make assumptions here also, right? So for the first row, there will be only one cell that is true, which is the cell that the cell with column value and the value from the input that is equal, which is 1 in this case. So here will be 1. So why it is true? Because it's simply because given the input a set of 1, can we find a subset that sum up to 1? So it is obviously yes, because we just pick 1 here, right? We pick the only number, which is 1 here, and 8, of course, sum up to 1, right? For everything else, it's just false, because we couldn't find a subset that sum up to anything here except n1, right? So false. So here will be our base conditions, right? Every problem that later we solve will depends on these values, right? So for any other cells, we can solve by making two choices here, right? Just as the top-down approach. For each cell, we also have two choices, which is either take the current number or skip it, right? If we skip the current number, then the answer will be right above, right? If we skip this number, so the answer will be considering the input does not including the current number, right? Sum up to the same value, which is the same column. So we just go up one step to get the answer, right? So we have two choices, either take or skip, right? And if at least one of the choices return true, then our cell will be true, right? We have two choices, and in this case, the first choice is skip 2, then the answer is true. So we don't need to care about the other choice, right? We just conclude that it's true here right away. So if here we have two choices, if we skip 2, the answer is right above, so it's false. So the other choice is to take 2, right? If we take 2, it means our current sum we subject the value that we are taking, which is 2, from the current sum. So it end up at 0, right? It equal to 0, right? So our problem is now come down to, can we find a subset that sum up to 0, not including 2? The answer is here. In this cell, it's true, so our final answer is true, right? Again here, 3. If we skip 2, the answer is false. But if we take 2, then we can narrow our problem down into a smaller problem. We take 3 minus 2 is 1. So can we find a subset that sum up to 1, not including 2? It is here, right? So one row ahead, one row forward, right? And the columns is 3 minus the value that we're taking, which is 1. So true, so this means it's true here. For 4, if we skip 2, the answer is false. If we take 2, the questions come down to, can we find such that sum up to 4 minus 2 is 2, not including 2, so it's here, false. So we have 2 false. It means it's 4 here also, right? Same logics here, we have false and false. I'm not gonna I'm not gonna go into detail of all the cells, so the logic is the same, so I want to save you time here. So for 3, we just take the value from above, right? In case we skip 3, but now it's 4 here, so we can try to take 3. 4 minus 3 is 1. Can we find a subset sum up to 1? Not using 3, but only 1. Got the answer is yes, 2. So it's true here. For 5, we cannot skip 3, so let's take 3. 5 minus 3 is 2. Can we find subset sum up to 2? Not including 3, so it's true here. So our final answer is true, right? It's 4 here, so we must take 3. 6 minus 3 is 3. Can we find a subset sum up to 3? Not including the value we take here. Yes, we can, so true here. Okay, the same logics for the last row. So at the end, we have our table is filled up, right? So come back to the original questions. Can we find subset exit? Sum up to here to sum. Sum is a last column, right? So if there's at least one row that its final column is true, it means we can find subset that sum up to S, right? So we check at least one of these values is true, right? So that is pretty much it. Let's try to code it down, right? The first thing for this problem is to generate a two-dimensional table. So two-dimensional table, we have rows and columns. Rows, yes, is the total number of rows will be same as our input length, input size. So nums dot length, right? Columns will be, so if 6 here, then we need 6 plus 1 columns, right? So the number of columns will be, because here we need the first row for 0 also. So sum plus 1, okay. So now we can generate a two-dimensional table using a utility function. Generate magic with rows and columns, okay. We can do it right away here. Generate magic. Let's make it simple here. This will take in rows and columns. We'll return first an array of side rows. Okay. You go fill with let's fill with no first, then I'm going to use a map. Map each row. We have an array of no value here, then we map it with another array, right? Map each row with a new array. Columns, we want to fill it with false, right? So let's see, not generate magic. Let's say 4 rows and 3 columns. Okay, 4 rows, 3 columns, exactly. So we're done with this one. Gonna initialize our DP, right? Gonna initialize the first column is all true. So for last column row of DP, right? So for each row, the first column of each row will be true. Okay, and also the first row, right? The first row that has the column equal to the first value in our set, right? It will be nums at index 0, right? This will be true also. So everything else is false. So we start we start filling up all other values, right? So we start from row equal to 1. We start from row 1, row less than rows, row plus plus. Let column also start from 1. Column less than calls, call plus plus. Okay. So from top to bottom, left to right. Okay. For each cell here, we have 2 choices, right? If we skip the current value, then the answer will be right above, right? So it means if the value at the cell right above, which is at dp at row -1 and same column, is true, then it means the current cell, which is row and col, will be true also. Okay. If this is true, I'm gonna use a value from right above, then just continue to the next. We don't need to count the other choice, right? So if this is not the case, we count the case that we must take the current number, right? So the current number will be nums at index is equal to row, current row, right? But here we only want to take the current number if our current sum, right? Our current sum here is greater than the current number, right? So that sum minus the number will be greater than 0, greater than or equal to 0, right? So only the column is greater than or equal to current num, then we want to take it. So dp of row and column will be the answer of questions dp row minus 1, because after taking the current number we want to narrow the input not including the current number, which is row minus 1, and the column will be our target sum now will be the column minus current num. Okay. Okay. So probably we can exit early if let's say so after filling every column, I'm gonna check if the dp row and calls, the last column is calls minus 1, right? If this is true, we can return true right away. And if we exit the loop and still not jumping in here, we can be sure that there's nothing valid, so return false. Okay, let's run the test. Just 15, number 3. I don't think there's any wrong here. Okay, it works as expected. So top down, bottom up. Just want to make sure it's running our test here. It's running the correct stuff. Okay. So that's it for our subset sum using bottom-up approach with two-dimensional table. So thanks for watching. See you in the next video.